All right, thank you, thank you. You know, serverless sometimes has a little bit of a latency. That's my excuse. So excited to be here. When I was invited to, or suggested to submit a talk here, I was thinking, what can I share? I work on Azure, and what can I share from a cloud provider perspective that could be useful for all of you? And what, the customers that we see in their journey, either starting on serverless, just considering it, or fully deployed production, or facing issues in productions, what have we learned? So, and tons of ideas came to my mind of stuff we could talk about. So I put a little bit of an ambitious plan, and if nobody gets hungry, we can go through all of this. If you guys get hungry, we'll get through some of this. But here's some of the things I observed that I prepared some material to just have a conversation to all of you about, and can be helpful as you go through your serverless journey yourself. So, and briefly, because I don't get to all of them, so some of it is on developer lifecycle, developer experiences. Serverless is really lovely on day 0. On day 30, things get a little different. Everybody thinks a lot about eventing, and it's all event-based, and a lot of it, it's HTTP, but what about when it's not HTTP? Like, what are the advantages? When should you pick one thing versus the other? The other thing is all of us cloud providers have to scale our infrastructure to deal with your needs for your applications, but that has consequences. It doesn't comes with a cost, so how do you overcome that in your application? Serverless is great. You build your application that stays stateless and short-lived, but real-world application also needs state. So how do you do that? And I want to talk about, just touch upon, and it's a little bit of a teaser on how the old enemies, which were serverless and containers and Kubernetes, are now becoming friends. It's kind of like the Avengers or something. So I'll tell that story at the end, and hopefully I leave on a good note and tell you get you all excited about tons of stuff that's coming from cloud providers and from the ecosystem in general. Sounds good? Okay. So, yeah, I should introduce myself in case you didn't see the name or introduce. I'm Eduardo again. I manage the Azure Functions PM team. And what's funny for me is, and I saw this tweet the other day, is I feel like my whole computer science life is focused on how to help people focus on business logic. Like even school, I did object-oriented programming, aspect-oriented programming. It was all about how to take away all the other code that you don't need so you focus on business logic. I feel like with serverless, we're much closer to kind of like deliver on that proposition. Particularly when I joined Azure, always been a high-level abstraction, worked on Azure App Service, last 6 years, but last 3 years really on functions. And the other thing, just a fun fact, in case you don't learn anything else, I'm from Brazil. I'm from Recife, is my hometown. And there's this place I went as a kid called Fort Orange. And I did my research last night on Wikipedia. It's actually the Dutch colonized. They actually invaded, but colonized sounds better. Brazil, and they built this lovely fort that is only used now as a touristic attraction, and it's a beautiful place. Anyways, there are 9 of them around the world, by the way. The Dutch went several places. A bunch of broken links on Wikipedia, so I don't know if the forts are destroyed, but anyways, I digress. Let's go into developer experiences. So how it's evolved. So for us in Azure, we started with, this thing, serverless, we need to make it super easy and deliver on it. So we built, in case you haven't tried, and I won't demo this part, on the browser, we made it super simple for you to start a function. You literally click the plus button, pick from a template, boom, it's running, has an HTTP endpoint, you can throw load at it, it's going to scale, you didn't have to write a single line of code. So, beautiful, lovely, but it's not a real IDE. Like, once you do need to start, doing some more things with code, like you need to debug, inspect your variables, you need to manage your dependencies, manage your packages, just the basic, like IntelliSense and all that, you're not going to get all that in the browser. The browser will always going to be a little bit behind in IDE power, although there are several things around it. Also, you've seen in the last 3 years, VS Code has picked up like wildfire. Like, I go to all these other competitor conferences, and they show VS Code on their screen. So we felt like, let's move the developer where they can be successful. So we focus a lot on now integration with IDEs. And being Microsoft, we have Visual Studio Code. So we did a much more streamlined experience. So that's all like the inner loop part. So when you think of more outer loop, like how you go to production, it's when DevOps picked up quite a bit. What's unique about DevOps and serverless, in my opinion, is you have much more of a distributed application. You have tons of components. You have your event stream. You have your data. You have to configure all that before you go to production. You should also, I know you all do, test your code before it goes to production. So how do you configure that, your test? So you need a DevOps pipeline. And the other part, and it's funny, the last year and a half, it's been a theme in all serverless conferences. It's how to monitor your applications. Although looks like you shouldn't use the word monitoring anymore. We should use observability. It's more encompassing. But the serverless applications will break. Sometimes your code, sometimes the cloud provider, might have an issue too. So how do you actually monitor that? It's so much harder on serverless now because it's so much more distributed. All those things run async, and they don't necessarily talk to each other. So I want to walk you through, let's just simulate, just so you see where we are on this journey of developer experience. Like if you want to resolve a bug, let's imagine we have a team of developers. Each one develops a different function. They kind of communicate with each other. They all get shipped to production. And there is a bug, and we need to solve it, to make it worse. You're jet lagged, you got woken up at night, and you have to solve a bug. So I can't duplicate my screen, so apology on that, but I'll move things to this main screen here. That was a technical difficulty I had. Let me get out of this, put my browser there. So imagine like all your application has functions and issues telemetry, right? Logs data somewhere. In the case of Azure, we log our data to this thing called Azure Monitor, which has a functionality called Insights. Once you log that data, as a cloud provider, we correlate your logs to build something like this. Actually, this is not the best view. And watch for this brilliant animation if I can see my mouse pointer. It's going to be interesting. I don't have too many clicks, though. OK. So that will, based on what gets executed in your logs, we can build something like this. So this is several functions. There is one that checks inventory, calculates shipping, process payment. And you can see where the errors are. You can even see the latency in between calls on your functions. You could use between these two functions HTTP or a key or service bus, you name it. And you can investigate errors. So, I got woken up at night, and I want to see what the errors are. Very likely they're here. So I can click on it, and now it samples all the executions to know where the errors could be. And those are the top failing ones. This one has way more failures, so let me look into it. And once I look into it, it's going to show the failure counts, it's going to show the performance, like the latency on those, and I'm going to show the top exceptions I'm getting. So let me go into this exception here. Again, sample base is going to try to find the most meaningful one to you. I'm going to click on that exception, and this is the view that I particularly like quite a bit. It's going to show the whole hierarchy of my calls up to the point where things failed. And it failed down here. I can see the failure. This is written for someone on the team that puts emoji on their exceptions. I do not recommend that. And what you can do is you get the whole call stack, our runtime as well as your code all together here. And if you don't care about the runtime, I care, but you shouldn't. You can just see your code. And here, I don't know if you can see behind me, you're going to see your code all the way to the line of code in which things failed here. So you get the exception with all the details, and you could go back to the code and fix it. So this is just to show like how the cloud providers can help you. Like a lot of the, you're doing serverless, but you need like those advanced features for you to be successful. All right, thing number 2, just check my time. I have 5 things I want to cover. OK, so event scale. So you guys might be familiar. You can send events to your application, or you can push, or the application can pull those events. You can decide for your serverless application to be triggered based on HTTP, as well as based on when you add something on a queue, add something to storage, right? Here are how those things work differently. So let's imagine an HTTP architecture. And again, this is biased Azure Functions architecture. No, different cloud providers do things differently. We do it better. OK. So sorry, that's a takeaway at the end. So that's a generic HTTP protocol. What happens now in infrastructure is we have common front ends. We actually share, in the case of Azure, app service and functions, the same set of VMs and machines. So the requests come, they go to the front end, and they hit directly your function. We built this logic here called scale controller. What it does is it monitors those instances. So as soon as those instances are getting overwhelmed, they can't process quickly enough, we provision more instances, and we do that very quickly. The way we do, by the way, this monitoring is a simple pinger. We ping. If the response doesn't come back quickly enough, we're like, you know what, let me put your code in more workers and so on and so forth. So that works great, but it is reactive. It's HTTP. There's only so much you can do in HTTP queue length, and we don't predict the future. We don't know what's coming in terms of an HTTP request. However, with events, you can a little bit predict the future, right? Because now, if you do a queue, when our scale controller, the first thing it does as you configure your code and you ship it to production is to check how many items are there. Like, let's say there are tens of thousands of items, and we know how fast the first item got processed. Now we can calculate in advance and say, you know what, to process tens of thousands of items, I need to put 10 instances in parallel right away. I don't need to wait until the events come. So I provision them a little bit ahead of the curve that I need. So you get much higher throughput that way. The other thing that we do is particular to our implementation is we embed the SDK that pulls those events in every instance. What happens is, as soon as I'm done, one VM or instance is done with execution, it picks up the next one. The other advantage of this architecture is the same runtime, which is the yellow box that you see, is what you get when you develop locally. So if you do Visual Studio locally, you're debugging and running, you can configure it to pick items from a queue, and that works the same way it would work in the cloud. The only difference is the cloud has the scale controller, and if you're running your own local machine, you can scale to 2 local machines, right? So you don't need that, but in the cloud we do. So those are the 2 different behaviors. The thing that's the takeaway here for you to be aware is if you want to do super high throughput, like we even have a blog on this, like let's say 100,000 requests per second, and that's a big number in case you guys don't do throughput tests in general, but if you want to get that big, you need to know those concepts and configure things to have an event source that's different than HTTP. All right. Now, so topic number 3. I think I'm doing good on time, so we can cover all of them. Now, serverless scaling. So we all love and talk about, you know, it's great, I only pay for what I use, there's no waste on serverless. However, here's what we think it should happen on serverless. Let's imagine I have a load, which is this white curve, which are requests coming, right? So what I want it to happen is, as soon as my first event comes, I want an instance to be ready right away to process it. When it's getting a little bit to the cusp of not being able to process more, add another one, and so on and so forth. And once I'm done, scale them back down, right? This is sort of the dream scenario. This is not what happens. What actually happens is, because we don't know when you're going to make a request, your load starts coming, and then right here, we start reacting. And that's when you get a little latency. But you get that latency repeatedly. As you add your second instance, you get that sort of extra latency again. And that's the cold start phenomena that you guys probably heard about, right? So here's what we've done, and I know this in a serverless conference can be controversial, but I'm going to show anyways. We did this concept of a reserved instance, which is you can preload workers, if you will, or instances. So you are ahead of the curve, literally. So what happens here is now you have one instance that's ready. As soon as the requests pick up, it starts processing the first event, we add the next instance. As the second instance starts getting used, we add the third one, and so on and so forth. So there's always a buffer, if you will. So even if you spike up the load, we can react to that real nicely, right? And we did this in a new offering that we're launching in a week or so. I shouldn't make promises in conferences. It's coming soon, which premium functions. So, but because, you know, I think it's better to show the actual thing instead of PowerPoint graphs, I'm going to actually show it to you how it works. So, and apologies again on my clicks because I can barely see because I can't duplicate it here. So So I have a few things set up. This is a loader test. This is SendGrid. But, and what I did is, in Azure, again, I have this live metric stream. This is true serverless. See the no servers online. It's like no magic here. OK, so we're going to start running our test. Let me just get the name of this. I'll load. Oh, the frequency of the monitor is a little odd. I don't know if we need to adjust that. My tech people. But I'll keep going. Oh, actually, now it's good. OK. So I'm going to start this test here. It's going to put, 800 requests over a minute. And I'm going to start running that test. And we're going to monitor it here to see how that works. As soon as I start my test, you're going to see the servers are going to pick up and start executing those requests. And we're going to keep adding servers, right? As kind of like that second graph that I showed. However, here's the problem. What you see here is the added latency. And I don't think I ever showed our latency numbers live. You're going to appreciate this. So we get all the way up to, and this is a very simple code, close to 5 seconds, right? Which is, I mean, a lot of scenarios just, you cannot afford this. If you have interactive scenarios, you have a customer waiting, 5 seconds is way too much. Eventually, this is going to, get to a reasonable number, so 77 milliseconds. Now, let's look at the other one. So this one, I have pre-allocated instances. Actually, there are no servers on this one. OK, one server. Wow, that was magic. OK, so we'll see how this one works. Someone backstage clicking stuff for me. OK, so Cart Premium next. OK, let's see. This is the one. So we're going to execute those tests here. And if I do have my preloaded instances, the other thing I should say about Premium Functions is it runs on a much better hardware too. And again, serverless conference, you can pick how many cores you have and how much memory you have. I know none of you want to worry about it, but Asari had scenarios in machine learning. She didn't tell you that some of these models, they're like 10 gigabytes or more. A typical instance, a serverless instance, cannot handle those things. So sometimes you got to say, I want something that can process my workload. Premium allows you to do that. And you're going to see quite nicely gets to like over 1,000 requests per second. And now we're going to look at the latency. You're going to see that the latency, even at the max it's only 80 milliseconds. You never really hit the famous cold start. And again, there's a little bit, if you're really picky, and I know you all are, it gets to 80, and then eventually it gets to 9 milliseconds. So maybe your application is still sensitive to this, but even interactive scenario, we can deal with 80 milliseconds, right? So this is really powerful, opens up a lot of things. Again, I know I'm breaking a little bit the serverless paradigm. Sometimes that's what applications need, though. All right. Man, this is a tough crowd. Nobody gets excited or claps. OK. OK, I'll keep going. Yay, this was awesome. OK. This is one before last one, which is Overachiever Functions. Don't do this at home, but I do talk to production customers. They do end up doing this. Here's how it works. People start with functions. They write a simple code, only does one thing. It's super clean. And then you need to make a code change. You add a little bit more. And then you add a little bit more. Now, your function is a mini monolith. It does so many things in a single function. And you're too, I shouldn't say lazy. You don't have time to this. You're just going to add the code right there sequentially, right? Now, this thing won't scale well. It's going to time out because even with, even the max execution time, I think Lambda is 15 minutes. So, you're going to get 15 minutes. It's not going to scale well. It's going to be hard to debug, right? Now, let me show this in code. And again, this code is going to hurt your eyes, so be careful. But it's a code that's a checkout process. And I'm going to do purposely waterfall, which is these things all have to happen in sequence, right? I need to check inventory, check shipping address, check credit card before I can perform a purchase. After I do, I have to do these other tasks that you see there. I also have to check for error handling in case something fails so I can react to it. Here's the code. Sorry about this. It's written by a PM, not a dev. OK. So what we're doing here is we're doing all these tasks, and each one of these tasks can take a variable amount of time, and you don't know how long they're going to take. So this is awful. This is just going to bring your whole process. He's going to be stuck trying to process this and not let anything else happen. So if you're smart, then you know a little bit more JavaScript than I do, you're going to do async await. So now at least you give the process some room to breathe for it to communicate and kind of like ask for help or whatever it's needed. But again, these things can take over 10 minutes. It can take a while. So still not great. It's a little bit better than the previous one. The main problem here, you have state. Like, is shipping address good? Is credit card good? This is state. This state's not being persisted. It's all in memory. Something crashes, you're back down to 0. You're going to start this process all over again. And if you had already done step 4, which is finalize purchase, I don't know if you want to do this all over again. You only want to do the following steps. So now, explain what happens in these cases. Here's why it happens. So sequential algorithms are easy. And nowadays, we learn everything from Wikipedia. We learned about Fort Orange, in case you don't remember. Here's what Wikipedia says about an algorithm. The set of rules precisely defines a sequence of operations. So, you know, don't criticize people that do things sequentially. That's what Wikipedia taught them. Now, and thinking async is not easy. If you come from a JavaScript background, maybe a little bit more familiar, the concept of promises and all that, but if you come from some other background, it might not be natural. Now, what do people do typically? They'll break this apart. Let me use a queue. Here's how that looks like. Now, all those 4 initial things you've seen, or any other scenario, you break into multiple functions. And you're inserting something in the middle that typically is going to be a queue, but could be whatever implementation you want. But now you're adding extra concepts in your code. Like, it's now like conceptual overload. The other problem is you don't see this into a simple project that you pick up. Like, it's going to be hard for you to just visualize this if you have to maintain that code. The other problem is what happens when function 4 fails and function 1 needs to know about it? How do you communicate all that back? So not great, and we're leaving a lot of work to you, the developers. So there are better ways to do this. So next step, you could use a workflow. Now, you can do these graphical designer workflows. They're great. They're powerful. You know, in logic apps on Azure, you have step functions on AWS. The hardcore developers tell me is like, you know, this is not code. Don't give this to me. This is like JSON. I don't want to learn a new way of representing things. Give me the code, because sometimes the orchestration flow is too complex for me to do that way. I'm like, okay, we heard you. And we did this a while back, but just recap in case some of you haven't seen it, this concept of durable functions. Those are functions that can run forever, and they store your state. They persist. They get exactly the state that you have in memory and puts into persistent storage. We use Azure storage in the background to do it. And we checkpoint the state of your execution a lot of times. So if something fails, we can pick up exactly where the execution failed and continue from that point on. And we as a platform take care of that for you. Here's what it looks like. Here's our code, if you remember, async await. And now we transform that into durable functions. Now, what you have here, and that's a durable function call, it can call other functions, and those functions are called activity functions. The main function is called orchestrator function. The sub-functions are activity functions. You call them, and they can now call into other functions. So validate inventory is one of those activity functions, and you can pass parameters to it. URL8 becomes yield. I'm not a JavaScript guy. I learned yield as I moved on. I thought it was, but it does essentially the same behavior. Allows for the process to spin off a new process, and the main one to kind of free up to continue executing. Now, what's going to happen in the background is that we're going to call that validate inventory with a queue message. The orchestrator is going to put a message on the queue. The validate inventory is waiting for that message to happen. When it happens, it starts executing. The orchestrator keeps track of where it's execution, whether it called another activity function, whether it's executing, whether it's completed. So it can pick up from any of these states. And then the programming style is going to be the same. It's just another function, just of the type of orchestrator function. Here's what our ugly code would look like. And it doesn't get less ugly, it just gets way more resilient. So now, what you have to do is you pick up durable function and you put that module in your code, and now you do those calls to call sub-functions, so the activity functions. So you change all those calls that you're calling methods to call activity functions. And now you have a persistent state. This is reliable, it's durable, and works much better. So, so the summary of all that is, there will be scenarios where you need state, and you need to sort of build your monolith or build your sequence of events. You still can use functions. Don't run away from serverless because of that. Just pick the right solution to do that. Again, could be logic apps, could be step functions, but it could also be durable functions if, if coding is your thing. All right. See how I'm doing? Okay. Here's the frenemies story here. So, and I'll tell you at least my journey on Azure Functions. At first, that was what, like 2 years ago, like we didn't want to hear about containers. And we'd get this question from the crowds like, but you guys do run on a container? We don't. We run on a virtualized environment using Hyper-V on Windows at first. And then we start having to support workloads like Python, where you have native Linux dependencies that are important. So we are forced into Linux kind of thing. And also because it's a trend and everybody's going that way anyways. It's actually our most growing workloads in Azure is Linux workload. Grows way faster than Windows right now. So we adopted that, we embraced. And we start supporting functions on containers. Even on our little command line, you can do func init, and it will start your container file. It has a Docker file in it that you can change. You can bring your dependencies. Asavri covered some of that. Now, Kubernetes also picked up. And the reason picked up, and I talked to a lot of customers. I can't disclose their name, but I talked to one that's a big stock exchange in the United States, but I can't say their name. And they're like, hey, all these stock exchange operations still going to be processed on my cloud, on my private cloud. There's no way I'm going to put this in your cloud or any other cloud. But I still need to communicate with the cloud. And my strategy to move to truly be hybrid and multi-cloud is to use Kubernetes. And the CTO had decided, and we asked, hey, are you using pods? How are you orchestrating? He doesn't know what pods are, and he doesn't care. But he's going Kubernetes. Hopefully someone else on his team does. But so it is a trend we have to embrace, even if we didn't want to, because there are tons of customers that will go that way. So how do we combine? How we build all this power of serverless, of function as a service, and put it in both infrastructures? So we do a few things. When you use containers and functions, we try to not force that concept into you. So if you are using Python functions, you might never have to touch a Docker file, even know what a container registry is or any of that. But if you do want to express your dependency that way, you can. So tooling for us is critical here. We take developer experience very serious. And now Kubernetes is a reality. What you can do, and I'm not going to demo it here, is you can take your function, you can deploy to a Kubernetes cluster. Again, your own on-prem, on a different cloud provider. Don't do that. It's horrible. Or on Azure itself, and your functions will run on that environment. We're partnering, and this is a little bit of a teaser, on some other companies to that scale controller that you've seen, to bring that to Kubernetes. So you can get serverless behavior even if you're on Kubernetes. And that's something we're looking at as Microsoft. Again, just a teaser. Maybe next time I'm here, I can demo that. And just a few closing thoughts. I think the way I see it is because I started on platform as a service and conferences like this that people didn't believe platform as a service, like, are you going to take the VMs away from us, things like that. And now it's a huge reality. I think serverless still sort of on the hype cycle. It's moving along. It's not really as adopted as it could be, so I think still growing in adoption. So the ecosystem needs to keep evolving. The partners, there are tons of ISVs, they're represented here as the cloud providers. The way we think about it is we reach our customers, we go to conferences, we go where they are, and we learn from them, and we keep improving the platform. And we run that cycle all the time. That's really our job. And the other thing we observe is the productionization and adoption blockers. One thing that, again, when the hard reality is serverless, some things are not ready, is I was serverless conference last time. I think Verizon has a slide on stage that said the great things about serverless, and then they went the rest of the presentation on all the reasons why they can't use any of this. They wanted to add custom encryption, they want full isolation on networking, they wanted to have all these things that without the cloud providers giving those functionalities, they couldn't go all the way serverless as they like to. So we need to start unblocking those scenarios. Now what you all can do is be open to possibilities. Like we operate open source fully, so if you don't like our product, file issue on GitHub. You can contribute, you can send PRs, but that's the way we want to open, like partner through open source. More and more, we're going to start putting more pieces into open source. All this work that I kind of teased you on Kubernetes is all going to start open source as well. Now, about me, because I talked a bunch, and I started late, but I'm going to end on time, which is awesome, because you guys are probably all hungry. But I'm going to be at the community area for questions, chat. There's Microsoft swag there. If you want to have a deeper chat, I'm in the country until Wednesday, and then hit us up on Twitter or through GitHub if that's the way you'd like to communicate. That works great. Thank you so much for having me here.